Welcome, everyone, to the AWS Partners Unplugged podcast. I am your today's host, Igor, and I'm a solutions architect here at AWS. Today, we are diving deep into a topic that's gaining immense traction in the data world, Apache Iceberg. And I'm thrilled to be joined by a fellow solutions architect who is an expert in the space, Anthony. Anthony, would you like to introduce yourself?
Hey, thanks for having me, Igor. It's great to be here and talk about something that I'm truly passionate about. I'm a senior partner at SA. Been with the company for over 9.5 years. Looking forward to getting into this conversation.
All right, so let's get started. Anthony, for those who might be new to this, can you start by giving us a foundational understanding? What exactly is Apache Iceberg and why is it becoming so crucial for modern data lakes?
Absolutely, Igor. So fundamentally, if you think about it, Apache Iceberg is an open source table format and is designed to simplify data processing on large, massive data sets in your data lakes. So think of it as your data lies in predominantly, let's say, Amazon S3, and you want to create a metadata layer to handle all kinds of processing within the data lake itself. Apache Iceberg is a perfect option. And, it was originally developed at Netflix, and then they open sourced it to Apache Software Foundation. And essentially, this is going to help data engineers solve some of the, really compelling problems, like, from a reliability, performance, and scalability point of view.
So it's not a storage format itself, but it's a way of managing and interacting with the data stored in other formats such as Parquet, ORC, or Avra. Is that right?
Exactly. It provides you that reliability, simplicity, and high performance for these massive data sets that require massive compute and also very high volume transactional integrity across, irrespective of actually the compute engine that you use. So think about it this way, like a lot of data engineers that we speak to in the field, they've started using Apache Iceberg because it's really fast, it's efficient, and it's reliable at scale. And it also keeps record of how data sets change over time as well.
That sounds incredibly powerful. What specific advantages does it bring to the table compared to traditional data lake approaches?
Yes, and I think this is why the data lake has slowly evolved, right? Like, some of the challenges we've noticed in the previous iterations, I think Apache Iceberg is solving that. So some of the key advantages I want to talk about is they have a very robust data management portfolio. And if you think about it, time travel, right? Essentially, you can query data as it existed at a previous point in time. And then if you want to roll back, you can revert your table to an earlier state. There's a ton of use cases that I can think of, in my past life, as a data engineer, when we had to go through records from, let's say, 2016 to 2020, but then one month was not backfilled. So for me to go back in time and look at exactly what state of data that was at that time, this is a very powerful feature. The other feature I can think about is data compaction. So this helps irrespective of the data format that you store your data in S3. You can optimize the data files for a better performance. And last but not the least, I can also talk about something that we have introduced in Apache Iceberg is the full schema evolution, which means that dynamically, when your table changes its schema, the changes are automatically reflected. So you don't have to go back and manually make those changes as well.
Now, I'm looking at these features and they sound awfully familiar. And I think I've heard this before, and I think maybe you probably think of the same things that I do, like the other formats. There was Apache Hudi, was Databricks Delta Lake. They had similar features, and I know some are supported by partners, some by AWS. So what do you think is going to happen? And maybe it's your personal opinion, not necessarily AWS. What do you think is going to happen to the other formats?
I mean, see, the other formats are continuing to exist, right? Like there are customers who are going to be using Apache Hudi, for example. Mm-hmm. We don't see them moving away right away. But the recent trend that we've noticed on the field is a lot of the new customers who are moving, especially from on-prem to cloud directly, cloud native, they are seeing the benefits of actually leveraging Apache Iceberg while they're doing the ETL and actually moving the data from the on-prem legacy systems. So if you think about it, a lot of customers who have been using Apache Hudi over time will continue to use them unless they have a compelling case that breaks their pipeline. But I think the newer customers are slowly starting to see adoption. And that's why we're seeing a trend where customers are moving towards that trend versus falling back to Apache Hudi, if that makes sense.
Yeah. And as a former data engineer, I can really appreciate finally having a common standard that multiple partners in AWS can use, right? And yes. Speaking of AWS, let's talk about how AWS integrates with Iceberg and how we enable customers to leverage Iceberg within their AWS environments.
Absolutely. I think at AWS, we provide really deep integrations for Iceberg tables, and we support that through various services as well. Primary example that I would think of comes to my mind is we can use Amazon S3 for storing Iceberg metadata and data files. And as far as the catalog is concerned, you can definitely use the AWS Glue data catalog, which is a popular choice for a lot of customers. And even a lot of partners do support AWS Glue catalog, which helps in tracking and storing table metadata. Also think about, how you can actually visually create and run your ETL pipelines through a Glue data catalog. You can actually do that through the Glue service itself. Any changes that are made in S3 are reflected automatically in your Glue catalog, which means that Apache Iceberg knows what's happening. That is one integration point. And the other one, which I am actually really excited about, and I can see growing demand, especially amongst massive enterprise customers like banks and healthcare and life science companies, is SageMaker Lakehouse. Essentially, SageMaker Lakehouse now offers an Iceberg REST endpoint that a lot of our partners can integrate with. And if you've noticed recently, Snowflake, announced that launch where they support that integration natively. Even Starburst supports Apache Iceberg on Amazon S3 tables as well.
This actually leads us perfectly to discussion of how our partners leveraging Apache Iceberg on AWS. And I know you have a long history with one of the partners, Starburst. You mentioned it just now. Can you tell us more about their integration with S3 tables?
Absolutely, Gaur. I think Starburst has been one of our long-standing partners with really a strong emphasis and focus on Apache Iceberg. They offer a really powerful solution by extending the Apache Iceberg connector integration to support Amazon S3 tables natively. What does this mean? This effectively means that the Starburst connector can now seamlessly integrate with your S3 tables.
And of course, when partners create integrations with AWS, we always work with partners. We always think about customers. We have customers in mind. So what does it mean for the customers? What kind of challenges does these integrations solve for them?
No, absolutely. I think these integration points helps customers get more options, right, for their data lake architectures of their choice. So what we are essentially telling customers is, hey, keep your data in S3, and depending on what your use case is and what your requirement SLA is, right? There are some customers for example, if it's a data scientist, they don't really care about sub-millisecond latency. They're just looking at iteratively taking a look at the data inside their bucket. Whereas if it is a front-end application, latency does matter. So there's different options there that the customers can use. In Starburst in particular, what they offer is this allows users to actually query and modify Iceberg tables and then federate their content with any other data source using Starburst connectors, right? So that's one of Starburst's differentiator, where they can federate across multiple data sources. Think of it as a data engineer's point of view. I can federate across these multiple data sources, pull them all, store them in S3, which is going to be your landing zone, and then leverage all the services that are governed within your SageMaker Lakehouse. So think of it as a one-stop shop or a unified data platform.
That's awesome. And it totally resonates with me. I've worked with data scientists, and they always just give me the data set, don't bother me with where it came and how I got it there. The only time they come back is when, and that's where time travel kind of is important, is, 2 weeks ago, there was a data set that was great, and can I get it back now? Well, that's fantastic. Let's pivot a little bit onto the maintenance. You can see the tables are maintained by the, you don't have to do compaction, you don't have to worry about history, schema evolution is there. So what is the general, how can customers start with the Starburst connector on S3, right?
Absolutely. It's a very streamlined process, Igor. And in fact, there's public documentation that I'm happy to share later on. But essentially, first of all, what you need is a Starburst enterprise cluster. And then you have an S3 table bucket with essentially all the AWS services integrated or enabled, which means that you have to have the necessary IAM roles and permissions that will grant access to the data within S3. And also you have to provide the Starburst IAM role, which will allow you to grant the permissions to use AWS Lake Formation. And for those of you who are not familiar with Lake Formation, essentially Lake Formation is a service that allows you to govern all the data within S3. And Starburst Enterprise actually supports Lake Formation. So then you go into the Starburst query editor, and then you can create a new catalog, or you can reuse the existing catalog that you already have your metadata in. And then you set the catalog type to REST using iceberg.catalog.type equals to REST. And this essentially configures you to use the REST catalog, right? So once this is set up, the Iceberg connector then retrieves the metadata from SageMaker Lakehouse, and then you can access the tables within S3. You can either read or write. And that's essentially how that workflow works.
Perfect. Thank you for that very clear walkthrough. Now, beyond Starburst, Snowflake is another major player in the data product world. How does Snowflake enhance support for Apache Iceberg and facilitate data interoperability with AWS services?
Yeah, that's a great question, Igor. I think as far as we're concerned, I think Snowflake has been a long-standing partner, and they're actively working with AWS actually to enhance support for Apache Iceberg. And they're also trying to facilitate the data interoperability within various data services. Think of it as you need a multitude of services and not just one service to do your job. So Snowflake comes in there for those specific use cases. Two of the main architectural patterns that we've noticed on the field between AWS and Snowflake is one that comes to mind the predominant use case, I would say, is essentially managing Iceberg tables with the AWS Glue Data Catalog, right? Think of it as, if I have to explain high level how this integration essentially works, is where you're going to use AWS Glue to ingest and catalog the information, and then you have the data sitting in Amazon S3 in Iceberg format. And then what happens is AWS Glue actually creates and updates the Iceberg tables metadata in the Glue Data Catalog. And now how the Snowflake integration comes into play is they integrate with the Glue Data Catalog to retrieve snapshot locations. And then they use this information to essentially read your Iceberg tables directly from Amazon S3 for any analytical queries. Now, the advantage of this approach is it significantly improves performance and reduces the compute costs, right? Which is something that our customers really want. And additionally, Snowflake also is, integrated between Glue Data Catalog. You can redirect all your queries, your read queries to Snowflake as well. So that way you can share the workload amongst different services as well. The second aspect I would say is you can actually manage the Iceberg tables with Snowflake directly, where Snowflake actually takes on the role of managing the Iceberg catalog. So that tracks snapshot locations. Snowflake writes the Iceberg tables directly to Amazon S3, so you're eliminating one step as well. And then you can use AWS services like Apache Spark on AWS that can also access the locations from Snowflake via Snowflake's catalog SDK. And then you can directly scan the Iceberg tables in Amazon S3. So this pattern is predominantly useful for customers who are not using the Glue Data Catalog, and they require Snowflake for both the read and write queries.
So that sounds great. They provide flexibility depending whether the customer prefers to manage the catalog themselves, or manage through AWS Glue or through Snowflake, and whether they need read-only or read and write capabilities from Snowflake.
Yep. I think precisely, right? Like we always advise our customers, especially in real-time scenarios, it's better to use a combination, right, of both the patterns that I just described. As read and writes operate on a really per table basis, and they can actually, skew the data architecture, right? Even back in the day when I used to talk about Apache Spark came out first, it was really critical to structure your data, partition data, because I think one bad table design could essentially mess up your whole workflow and structure. So that's essentially what customers need to keep in mind as well.
Finally, for organizations that already have large data lakes built on top of formats like Parquet, such as Parquet and ORC, is it a complex process to migrate to Iceberg to gain these benefits?
Not really, actually. So it's not as complex as you would imagine, which was surprising at first for me as well until I tested it out. So you can actually easily convert existing Parquet, ORC, and Avro-based, files on Amazon S3 to Iceberg format. And you don't have to actually rewrite all the underlying data files. So this is really one of the value adds that can be, differentiated, right, when you talk about costs and saving time. There are also several Iceberg table migration options that customers can leverage, such as snapshot, migrate, and even add_files. So for example, you can use add_files option, and then you can use Glue to generate the Iceberg metadata and statistics of the table. And so then you can actually use this information and you don't have to rewrite anything or any of the underlying data structures.
So the underlying data does not move at all, right?
Yeah.
Perfect. Now, I just want to quickly ask you about, and maybe again, it's your personal opinion. It sounds like there are great benefits for the customers. Where do you see other partners going with support for Apache Iceberg? Do you recommend them. I guess we recommend them to support Iceberg, all of the data analytics and like even non-data analytics partners, right?
Yep.
To support Iceberg.
Yep.
How do you see it's going? Where is it going?
I think today's, as my personal opinion, I would say like if I had this conversation 5 years back ago with customers, they would tell me, hey, Anthony, the main focus for us is cost optimization. But today, if you talk about it, customers are first starting off with the conversation on ease of use. What is going to make my life easier? How can I save dev time? How can I make my life easier by using partner solutions, right? And so that's why we are recommending that we give the choice to the customer. Like we're saying, hey, keep the data in S3 and keep it in this landing zone. And then depending on your use case and what you really support or what you have and what kind of knowledge your team has, you can leverage partner solutions. And that's where we're encouraging partners to actually start supporting this methodology because more customers are going to be asking for it. And it's super critical, like you said, Igor, that the data analytics ISVs do support this going forward because we see a lot of customers moving in that direction. And I can see that exponentially growing over time.
So I think this is a great news for adoption. It sounds like Apache Iceberg combined with AWS services and partners solve specific problems for customers. So it's a win-win-win. Customers win, AWS win, and partners win by supporting Iceberg.
Absolutely, Igor. I think it really empowers data teams, right, to think about, how do you overcome complex data lake configurations, performance bottlenecks, how do you enable consistent data governance, broad access to a lot of the analytical capabilities that they have before their disposal. It's about building a future-proof data architecture. So that's why I urge customers to think about this right now, because you're building a futuristic data model, essentially, for your organization.
Well, Anthony, this has been a very insightful conversation. Thank you so much for breaking down Apache Iceberg and its powerful integrations with AWS and patterns of how our partners implement it.
No, my pleasure, Igor, as always. Thank you so much for driving this. It's always a pleasure to share insights on how customers can build more efficient and powerful data lakes. Thank you.
And to our listeners, thank you so much for tuning in to another episode of AWS Partners Unplugged. We hope this deep dive into Apache Iceberg has given you clear understanding of its potential. Join us next time for another exciting topic on our podcast. Goodbye for now.